Well, welcome. It is November 3rd, another day of Codevember 2016. So, alright, what are we looking at today? Today, I wanted to do something like one of these Japanese wave patterns. I'm just in that kind of mood for today, and I found a couple other image examples. This one's an Art Deco. I'm not sure what this one is, maybe some kind of wallpaper pattern. And another Japanese one. So that's the idea that I want to look at today. Maybe we can do some like random color generation if we get the basics done. Shouldn't be too hard. So let's jump right in and get started. So I've still got my folder from a couple days ago that we started on the first day of Codevember this year. And I'm just going to make a new folder for day 3. And let's make a new main in here. New file, main.elm. I'm going to continue using this render package by Quartz. And we found a few problems. Actually, on the first Codevember day, we found a couple bugs in this, and I mentioned them on GitHub, and 2 of them have already been fixed. So the author of this is really responsive and has some interesting plans for the future of this package. Alright, so I'm just going to grab, let's see, all we really need are these 2 modules to start. And then our main is going to be, I will just grab this again. This gives us the width and height. Let's put a group in here, and then in here we can make a rectangle of 750 by 500, and we'll solid fill it with our background color, which let's make it almost white. How about 240? And let's see, I have one compile error, color.rgb. Great, and then let's try running this. So I have ElmLive installed as an npm module, which we also did on day 1. And I'll just give it the path to the Elm file we want. Everything compiled. Copy this and open it up in my web browser. Okay, and I think that's what we want. All right. So the way I'm breaking this down in my head is we kind of have this shape that we need to make, and then it just gets tiled over and over. And maybe we can have some different variations for the tile as well. Like this one over here has alternating patterns. So that's pretty cool. All right, so this is just a few concentric circles again. So let's actually make a new thing and just call this a tile. And let's define it here. And the type for this is going to be a form, which comes from this graphics render package. And ours can produce a message. Hey, Buddhas, welcome to the chat. All right, so we're going to have our tile. And this will be an ellipse. I think if I'm starting to memorize some of this API because I've been using it 3 days in a row. So we're going to have a width and height. Let's say the width is 100, 100, and let's do a solid fill on this one. Color.rgb. Actually, let's use let's use a slightly different color for the moment. How about 200? All right, there's our nice little circle. Then let's stroke a few smaller circles inside of there with an alternate color. So we're going to turn this into a group. Stick that in a list. Then we're going to have an ellipse of, let's say, 80, 80. And I don't want a solid fill. I just want a border. And we learned yesterday with this API that we have to say solid fill with border, and then give it a color, a transparent color, and then the width of our line and our line color. So let's make this maybe like a dark blue. So maybe 3070, let's try that. And this is RGBA because we need an alpha here. Cool. Okay, I want to make this a little larger, maybe 85. Cool. And actually what I want to do is extract this border creating function so we don't have to put this transparent everywhere. So I'm going to take this and call this border. And just do that. Great. So then let's draw a few more of these. How about 65? Is that going to be small enough? Too small, maybe. Actually, let's increase the width of the lines. Okay. Seems all right. 44 for 45. Cool. Let's start with that. And I also want to try drawing some lines straight down from that as well. So let's do a rectangle, and we'll do this 100 by 30 maybe, with this color. Oh, I had these backwards. Is this height and then width? No, that seems right. Oh, I see. This is the radius for the circles. So this is actually 200 wide. Cool. And then let's move this down by 50, 40. Nope. How about 30? There we go. So what I'm doing is just kind of working with the top half of this. Actually, I guess we could make this even bigger. How about 100 and move it down by 50? There we go. Okay. And then I want to fill in some lines going vertically down the side. So let's see. Do we have a function that can just draw a straight line? We can make a rectangle. Oh, here's a line. So we can take a line segment. And then how do we draw a line? We can draw a solid line with a width and a color. Okay, cool. So let's try that. So we're going to have a segment from x is going to be, I guess, negative 45. And y will be 0 to negative 45 comma negative 50. And I spelled segment wrong. Then let's draw this as a solid line with the same line style that we're using here. Cool. Okay. And apparently y goes positive. Great. So let's draw a few more of those. So we're going to have 3 on the left. So then this becomes 65. This becomes 85. And actually, maybe what we should do is introduce a little function here. Let's make an arc, which is going to take a radius and have that do both our ellipse. So this will be a group It'll have the ellipse in it, and then it'll also have the line segment in it. So then we can just say arc 85, and that will replace that stuff. Oh, interesting. I see. So we actually need the rectangle in the middle. So I guess this would be kind of inefficient in terms of the elements that are getting put on the screen. But it should work if we do it this way. There we go. So there's our outer arc. Then we can add our arc at 65 and our arc at 45. And I didn't extract these variables. So all these 85s become the radius. Interesting. And we also need to draw these in a specific order, starting with the outermost one, and then the width of this should just be r times 2. There we go. Cool. So we've got our basic shape, at least for now. We could modify this in the future. So let's go about positioning these tiles then. So we're going to have a row of tiles. So that means, let's just start with a few examples. So then we'll move x by negative 100 and y by 0. Okay, how about 200? Maybe 180. All right, there we go. So then let's take a range. So we're going to need about 6 of these, I think. So we'll go from 0 to 6. We'll take each of those integers and convert it into a tile that we're going to move by some amount, I times negative 180 and 0. And then we'll take all those and put them in a group. There we go. And then we're going to take the whole group and move it to the right. Actually, let's do it this way. Let's go forward, and then we'll move it back to the left. There we go. Cool. So this gives us a row. So let's create that. Cool. So we've extracted that as a function. Now we're going to have another row that we will move down by some amount, maybe 100. Cool. There's our second row, and I guess we also want to shift it to the left or right. So maybe 50. Actually, I guess we should do half of the amount that we are moving by. So that would be 90. So we should maybe extract that to a variable. So this is going to be a width. We'll call that W, tile width. And then row now takes 180. And let's extract this into a variable in here. Tile width equals 180. So then 180 becomes that, and this is going to become tile width over 2. Cool. Hey Cortland, welcome to the chat. Yeah, that was a cool example with the Kotlin Android Elm architecture. Yeah, that sounds really cool. I actually have an open source Android app that I have been using as a to-do list for a while, so maybe someday I can stream refactoring that to try that out. All right. So where are we at here? So let's add a third row. And this one is not going to be shifted left or right, but it's going to be moved down by 200. Cool. So here's what we want to do for this. We're going to take another range, and I think again we'll want about 6 of these. And we're going to map it to, for each index, we'll make a row with the appropriate tile width, and we will move it by 100 times I. And then if I is divisible by 2, then we're going to shift by tile width over 2, otherwise 0. Okay, and the formatting for that code is going to get crazy. And then we're going to stick that all in a group. All right, so what did I mess up here? Move is expecting the second argument to be a float, but it is an int. Okay, so we have to float this I. Cool. Yeah, I'll definitely let you know if I do an Android episode or refactoring. Hopefully that'll go well, trying to use Elm architecture for mobile. Alright, so let's kill these other extra tiles. Then we need to just shift this whole thing. Actually, I'm going to take this move out of the row and create this whole thing, and then at the end we will move this by -300. Let's try that. And we need to go a little farther here. Cool. So that's fairly good. Let's see. I think I want to shift these over a little bit more. So let's make our tile width be 200. Actually, we can go a little smaller than that, 190. Yeah, there we go. Cool. So that's a good start. Maybe what we can do next is choose some random colors. So to start that, we're going to do what we did yesterday and convert our main into a program. So that means this will become our view function. Then main is going to be a program which takes no flags. And then we have to import a couple things. Import HTML app. I guess that's the only thing for now. And we'll have a program. In it is going to be a tuple with just a unit for data for now and no command. Let's see, then we're going to have subscriptions, which is no subscriptions for now. Update is going to do nothing for now, and our view equals our view definition. We don't take a parameter here, so let's see. And our command, or our update, needs to return commands also. Cool. So there's our program. So what I want to do is generate something. So let's make our model. Our model is going to be, for now, just a color. And I need to import, oh, we already exposed color from color. Okay. So our model is going to be a color. Then our view is going to take a model. And for that annotation, we need to import HTML. And then our color for now is going to be this lovely line color. And then here, our update function is going to return the model. All right, now what's missing? And now actually our view function does take a parameter. Got it. Cool. So now let's change this color a little bit, and let's make it like a pink. And then let's change our code to actually use the passed in color value. So we're using this blue color here in the tile, so we need to extract a parameter here first. So then all these places are going to be replaced with color. Then wherever we use tile, we need to add that as a parameter. Okay, so we'll need to pass the color as a parameter here also. And then here where we call row, we're going to pass model.color. There we go, and we've got our pink. All right, so now let's actually generate this randomly. So we're going to use random.generate, and I'm still not super familiar with this, so let's look up the docs. So generate, we're going to give it a function to convert some value into a message. Okay, so let's make a message. Type message, new color, and it'll take a color. So now we're going to make our command. So we'll say random.generate. And when we get a value produced, we're going to turn it into a new color message. And now we need a generator for colors. And there may be one, but I want to generate colors with specific constraints. So let's define this, and we're going to create a random.generator of colors. And I think we need to import random. All right, so our color generator is going to basically just use other generators and then use map3 to apply the RGB function. So we're going to use random.map3, and we're going to call color RGB with 3 values, which will also be generated randomly. So we'll use the int generator for that, random.int, and for the red component, we want a value. I think we want relatively low values here. So I'll just use a random int between 0 and 100 for all of these. And then we need to write our update function, a real one this time. So our update takes a message and a model and gives back a model and a command. So we'll do a case statement on our message. And if we get the new color message, then we'll stick that in our model. and then we'll have no new commands after that, and that's all we need. Great, so we've got some kind of dark green color here, or lighter gray, an orange. Cool. So that's pretty good. What I also would like to do is make this choose whether to create a second color, and we can alternate colors in the tiles. So like, let's see, one of these example images, yeah, this one, and I've had alternating colors. So let's set ourselves up to do that first of all. And I think we can just make our functions general enough so that tile will always take a single color. And then the row is going to alternate colors when it calls out to the tile. So row is going to need to take 2 colors and an int, and it gives back a form. So this will be color 1 and color 2. And for now, when we call row, let's just hard code color.red so we can see it. And this is color 1 for now. And what's wrong with this? This is actually a float, not an int. That's fine. Cool. So now let's do our alternating. And we're going to, let's pull this out into a let statement. And we'll call this make tile. It's going to take the index. And then this will be make tile. So we've just converted that anonymous function to a real function. Cool. And now we have a bit more room. Color 4. And we'll say if I mod 2 is 0, then we'll return color 1. Otherwise, we'll return color 2. Then we'll use that function, color 4I. And let's see, what did I do wrong in here? Move is causing a mismatch. It's expecting the first argument to move to be a float, but it's actually an int. Okay, so I think that's because we need to 2-float the I. Cool. This is not, this is not the arrangement I was expecting. Oh, interesting. Actually, in this case, they just alternated for each row. That totally makes sense, now that I'm thinking about that a bit better. Let's see. Maybe we could do it even slightly differently. Let's do every third one. Let's swap these also. And then we could shift these farther. So then when we create each row, we're going to shift it by tile width over 2 plus tile width. Yeah. Okay, and then we need to shift this entire thing farther over. So we're on the screen. Yeah, there we go. I like where that's going. Okay, so now our next goal is to replace this constant red with some other randomly generated color. So where do we use red? Okay, we use the red here. So let's change our model also to have a color 1 and a color 2. Then we'll have the randomness change color 1. Then we'll replace this with model.color2. And here in our init, we'll also replace these. Color 2 will be maybe the blue that we had earlier. That was what, 10, 30, 70? Cool. So right now, the extra color is always this hard-coded blue. So now, let's see. I think we can maybe just end up generating random models completely. So instead of generating a color, let's generate random models. And then we'll change this to be called new model. And it'll get an entirely new model. And we'll just return that whole thing when we generate one. And then we need to, let's make a let statement in here. This is going to be color 1, a generator for color 1. And then we're going to use random.map2 to create our model. And then we'll use two generators, a color 1 generator and a color 2 generator that'll be defined here. And then our color 2 will, okay, for now be the same thing. So we've got that working. But I'd like the second color to be in a slightly different range. So let's bump this up to maybe between 80 and the 100 can change to maybe 180. That sounds good. Yeah. There we go. Cool. Let's see. Maybe we can do one last thing before we finish, because I feel like this is a bit static when we reload. Like everything is always in the same place. So I'd like to just add an offset to the model. Let's, I guess, just call it shift X, which will be a float, actually, and a shift Y, which will also be a float. So that means our generator here is now a map 4, and we're also going to generate a float for each of those between 0 and I guess let's just do it between 0 and 1 and let that be a percentage of shift, and then we'll let the actual view use that to shift by a percentage of the tile width. Cool. So we have our model. Then we're going to have this whole thing, and then we're also going to move it by X should be model.shift X times the tile width. And do we need to float that? Oh, no, we need a Y amount to shift. And we should actually do this negative, I guess. Yeah. There we go. And then let's also shift by the Y amount. So this will be model.shift_Y times, I think maybe 200. And we should also do this negative. so it all stays on the screen. And it looks like we need one more row then to make sure this stays within range. Cool. Yeah, great. So we can maybe add some other random. I'd be kind of interested in changing, adding some random options for how these colors are assigned in different patterns, and maybe have it shift in different ways. But I think I'll leave that as an exercise for the future. So thanks for tuning in today, and I will be back tomorrow with Codevember. What'll it be? Day 4. Cool. So if you're doing any Codevember projects yourself, be sure to let me know on Twitter, and I will see you all next time around. Bye.